Okay, question 8. The bacterium E. coli was cultured in a growth medium containing 0.6 millimolar of glucose and 0.6 millimolar lactose for 180 minutes. Glucose and lactose concentrations were measured every 20 minutes. Results are shown. So we've got time going down the side, and we've got our glucose concentration and our lactose concentration. Okay. Using values from the table, describe changes in the concentration of lactose over the 180 minutes. So we treat this like this is here, something that had been plotted on a line graph, and you're just asked to describe. So at 0, the lactose concentration is 0.6 millimolar. It remains that until 60, and then it decreases to 0 by 180. Treat it exactly like it was a graph and you were having to tell people where the points were, okay, where the points change. And that's your mark. E. coli breaks down lactose using the enzyme beta-galactosidase as shown. So lactose with beta-galactosidase gives you glucose and galactose. Beta-galactosidase is produced by E. coli only when lactose is present and glucose is absent. Using information from the table, identify the time when E. coli started producing beta-galactosidase. Right, so only when lactose is present and, this is important, glucose is absent. So lactose is present is the whole thing because we started at 0.6, so I'm going to just get rid of that. Okay, so we have lactose is not the problem, it's there all the time. But it has to be and glucose is absent. This is when glucose disappears and we still have lactose present. So when did it start producing beta-galactosidase? 80 minutes. Suggest a benefit to E. coli of producing beta-galactosidase only when lactose is present. Now this is just as kind of a truism for anything which you don't produce when you don't need. It means that they're not using energy or amino acids or anything else, okay, when it's not needed. So they're kind of saving resources. In terms of activation energy, state how enzymes increases the rate of reaction in living cells. In terms of activation energy, enzymes decrease activation energy. So that's really all you can say. Okay, this is your kind of energy profile diagram. Here's your reactants, there's your products. This would be a breakdown reaction happening because we're releasing energy from this one. This is your normal activation energy here. And this is what happens when I stick in an enzyme. My activation energy is reduced, which means that my reaction can proceed faster. They literally just want you to say decreases activation energy, and that's it. And that's the question.